computer so you can see them.
Oh, perfect. Oh, wave. Hello. Hello from Munich, by the way. I'm here in Munich.
Malo ću da odvolim, možda ćete bolje da vidite. Okay, something like this. Okay, great. Do you have a presentation to share?
No. Yes, I have a presentation to share. Of course.
Okay.
Of course. So, can you see the presentation?
Yes, it's a little bit small, but we can see it. No.
Do you have a TV or a beamer or something, or how do you present?
Yeah, we have a projector. Okay. Biće ovako malo manje jer iz nekog razloga ne znam da smanjim naše slike, ali vidi se sve. Jel vam okej? Ko je slabovit, neka pređe napred. Jel znaš ti to? Change layout. To? Ne, ali bilo je ovde. Ovde. Change layout. Možda može da se tu stavi spotlight ili ne. Eto. A falit će ti ćoško posle. Može to. Okay. Okay. We made it. It's nice now. You can start. The floor is yours.
Perfect. So, hello everyone. I'm Alex. I'm a developer advocate and also Google Developer Expert for Flutter, and also freelancer. So I do a lot of things, but mostly with Flutter. And also I'm an engineer. So also for the last 10 years, I'm an engineer for mobile applications, and started with Android and also going to web and so on. And at some point, I got stuck with Flutter. And this is also where my career goes. So the last 4 or 5 years, I worked on project with Flutter, and also that's where I got the title of a Google Developer Expert. Yeah, and today I want to show you something about the Flutter Shaders on tablets, where pencil drawings come to life. If you see my screen, I have already a pencil here in my hand and a tablet right next to me. But I will show this later as well. So first, I want to do an app showcase and deep dive into touch events, and then go shortly into the shaders, and then go to Flutter Shaders, and then show you the world of shaders. I know this is a very, very strange composition of topics in the end, because you will probably never see a talk again about touch events and shaders, because they could not be more apart. So let's start with the app live showcase. And this is also the reason for this talk, also why I give this talk, or I created this talk, because I got a tablet and with a pencil in the end, and I thought, okay, hey, why not do something with Flutter in the end and try out what works and what not. And I also wanted to use the pencil, and let me show you this. Now I created this application. Let me check where this is. I think the connection was really wait, I will do this here. So this is my tablet, and I can touch it, and I hope the frame rate works over the internet. It's not lagging or something. It's actually pretty fast, and I can move the calendar with 2 fingers. So this is like a touchable app, of course, and I can zoom in by pinch and zoom and move around. And by the way, this is completely done in Flutter. And now if I touch with 1 finger on the screen, I can do nothing at the moment. So it doesn't write something, and it doesn't do anything. But when I touch, for example, with a pencil, I can go inside and I can actually write something. I can say hello, everyone. And this is where I thought, hey, why not doing a calendar? Because this is how I manage our appointments here in Munich with my wife and my child. And this usually we go here and say, hey, this weekend we have someone is coming over, and hey, why not using the pencil for that? And I thought, okay, I have such a big screen. What about shaders? So I wanted to try out shaders, and I don't know if you know shaders, but let's just activate one shader now. And at the very top left, there is this button here. I don't know if you've seen it. At the very top left, I can move there with the cursor here. I can activate the shader. And now if I write something with the stylus, so I activate the shaders. And this, for example, is a shader that is written on the widget itself. So just give an example, but I will showcase some other shaders as well. So, and also what a shader is. But in the first place, I wanted to write something. I want to work with shaders. And now, how does this work? I will go back to the presentation again. And you can download the app. So it's also an open source app. So if you want to go to the GitHub repository at the very bottom left, you can see the Stift Flutter app in my account. You can see all the code. You can download it. You can also download it on the Play Store or Apple App Store and try it out yourself. Let's start with the deep dive into click events. If you work with Flutter or some other technologies, you could probably do something like a gesture detector, where you, for example, tap on something, right, on a widget, and then you will fire an event, and you can print something or do whatever you want with the tap event. And I thought, okay, what can I use to make the writings possible, right? So write something and connect those dots to a line or to a writing, and like how can I do that with Flutter? So I looked at the gesture detector methods. So this is the gesture detector, and this is like all the methods from the gesture detector, and the gesture detector tries to recognize the touch event and tries to put it into one of those functions. Let's say here at the very top left, there is this on tap event, and of course it's a tap event. You click it once, and it will fire on this method. And if you tap up, so you move the finger away, so it fires this method. And you can also do the on secondary tap, on tertiary tap, on double tap down. So there are a lot of events you can use just to figure out what the user tries to do. But all of this, so I wanted to write something. So I need to have like something like a continuous event of touch event. So I looked at the very bottom right there. There's this pan down, pan start, pan update, ping end, and also the scale events. So I looked at those events and I thought about, hey, okay, what can I do with those events? And if you look at this case start event, there's this pointer counter. So at the very top left, you see the pointer counter. So you see how many pointers you basically touch here. And here's an example. So if this is the update event, the start, update, and end event. Usually the update event is for if you move something, so it updates the event. And if you end it, it will, of course, fire the end event. So if you, for example, use 5 fingers, you get the pointer count of 5 there. And the focal point is, in the end, just one point you will receive for all pointer events in the end. And this is the center of those events. So if I use 2 fingers, it will give me the position of the point in between those events. And then you have the scale event. So let's say if you move your fingers away, then it will of course increase or decrease in the end. So yeah, doesn't really work for the calendar app. So I want to draw something, so it doesn't work because I really need one point and we follow those points in the end. Then I looked into the pan start, pan update, and pan end event. And okay, I want to figure out, okay, I want to, does the user touch with the finger or with the stylus or with the mouse? And there you see on the pan start event, you will get the kind of the event. And this is the touch event. So it really tells you, okay, this event is a touch event, a mouse event, a stylus event. And I'm not sure what inverted stylus is, but there's probably some stylus that inverted something, and there's a trackpad and unknown events. So you will really know what the event is about in the end. You also get the local position for each point. So let's say if you move something, then it will be there. Looking at the events. So if I touch with 2 fingers, it will fire 2 events. So at the very top left, you see one position on the tablet, and then another one. So you cannot really say, okay, this first one belongs to the first finger, and the second one belongs to the second finger. Of course, you can somehow mathematically figure out how far away they are, but somehow it was just too complicated, right? So then I thought about, hey, okay, this kind of works, but it's in the end very hacky to implement. So I tried to think about a different way to use that. So in the end, so all of these events doesn't work for my use case. And I looked into more options, and then there was this listener widget. And the listener widget is more a generic touch event listener. And then you also have the pointer hover, the down, the move up, the up, and also the signal and whatever. And we look into the move event, and I printed whatever is inside the pointer move event. And there you see the really raw data of the click event or the touch event in the end. And here there are a lot of values you can look in. And I wanted just to point out some of those events. Let's look, for example, at the pressure, so which is I like very much. And on the left side, you see the touch event with the finger. On the right side, you see the stylus event. So the pressure, let's say, if you use your finger, you always have 1.0, right? It won't change. So you cannot really press harder and then the value changes. It doesn't work. But this works with the stylus. So if I really press harder or lesser, then the values are decreasing or increasing in the end. So you can really say, okay, I can make this line thicker or thinner depending on the pressure, right? I can use this data in here. The size. So there's an event of size, and this works with the touch, but doesn't work with the stylus. So in the stylus, always 1.0, but the touch event will give you the size of the finger, which I think is pretty cool. So it's in this case here, it's very, very low numbers, but here it increased a little bit, and it decreased and increased a little bit. So there you can say, okay, how hard the user presses in the end. And of course, if you have a big thumb, it will probably have a bigger size, or a smaller thumb, you will probably have a smaller size. So you can use that for custom events. The touch event, the kind event, you also get the kind of the touch. And this means, like a touch event, you get the touch kind, and the stylus event, you get the stylus kind event of those touch event, which also works for my use case. The pointer, which is also very interesting. The pointer event, this is an ID that gets fired. Let's say if I touch it once, it has an ID of 33, and then I use the stylus, and it has 34, and it increases, which I think, okay, this is kind of interesting. So let's look what can I do with that. And if I printed some testing numbers, so let's say I press the finger or stylus, doesn't matter, and I have a position with the pointer ID of 36. Then I have a second finger, and the third finger I use as well. So I get the position of each finger and can connect it with the ID. And if the first finger moves, I get a different position. In this case, it's the same position, but I have a second listener, like a second event of the first finger with a new position. And here in this case, I moved again, not really, so it's still a new event, but with the same position. Let's look at the 59. So I have 105 X position, and here I have 104. So I moved a little bit the one of those fingers or touch events. And I can use the ID to follow touch events, right? So if I have 5 fingers, I can move around, and I can find out basically where the touch event is, and I can connect those events for, let's say, drawings or writings or whatever. Yeah, and this I use for the tablet event, and I think this is like the deep dive into touch event. I can go inside the app again, and I can, let's say, I didn't use really the touch, what's it called, the pressure event or the size event. I can also increase the, let me just disable the shader for now, and I can increase it, so I can use that to write, or I can also change the number. But what I also could do, I could basically increase the size of the touch event. And those events, so if I don't know if you see that, there are points, and the points can be, so I just connect those points with a line or just a path event. So I can have a path of points, and I connect them via just lines or curves. So whatever you want to do there, so you can do that. And yeah, so this is how I achieved the drawings on my calendar in the end. Cool. I can also, I disabled the finger, but I can also enable it if I push this button here with the hand, so it's turned off. And if I push it again, I can use my finger as well. So this also works. I can enable both of them, right? I can use two fingers to zoom and pin, like a pinch and zoom. And yeah, I can also delete something. So this is how I did this use case, which I really like, because I didn't know this was possible in Flutter before. So I just worked on this. Cool. Then I would, let me go to the presentation here. All right. If you have a question, let's keep it for later, because let's go into the world of shaders. And I'm not sure if someone of you did already something with shaders. Maybe raise your hand so I can see it. If you did something with shaders. Nobody? Okay, because this is, I think, the most interesting part working with Flutter. And also the most awesome part. And if you work with Flutter, so let me maybe raise your hand if you already work with Flutter. Okay, some of you, so really cool. So you probably know the widgets, right? The widgets, and also maybe the custom paint widget. And usually you say, okay, widgets, so everything is a widget. Widgets are drawn on the screen. So let's look at the shader again. So this is one widget, right? So each cell is a widget. And oh, let me turn this off. Yeah, so each cell is a widget, and also the text is a widget, the line is a widget. So everything is basically a widget. Also the buttons at the very top left, so you can move the years. Here at the very top left, everything is a widget. And every widget gets drawn to the screen. And the screen itself is a render object, and everything is connected to the Canvas API. And this is how also Flutter works. So Flutter works that it draws the elements on the canvas. And the canvas exists on Android, on iOS, and also on Windows, on Mac, and also on web. And you can use this canvas to draw something on it. And widgets are just drawn on the canvas, right? So what you see inside the Flutter app is just a drawn app in the end. So it draws the buttons. When you scroll it, it redraws the screen. So it's just a drawing of an app. And this is also how Flutter works. So if you say everything is a widget, you also say everything is a shader, because our Canvas API, everything that you draw on is drawn in with a shader. So you can say basically everything is a shader, and everything is drawn on every pixel on the screen. And also we have some custom painters. So you can, this for example, a custom painter I use for the drawings. So the drawing, when you move your drawings, this is just done with the custom painter. And just to explain how shaders work, this is a piece of code. I think I have this example here. This is a GLSL fragment shader. This is the piece of code that gets executed on the GPU. Let's say here, this is just a color, like a vector 4, like a vec 4. And this is 1001. And if you look at this RGB, so the colors red, green, blue. So red is 1 and blue is 0. So it will paint a red shader in it. And this is the alpha channel, so it's just visible for everything. So it's just visible there. And this code gets executed on every pixel on the screen. So you can imagine that if you have a screen with 1 million pixels, this code gets executed 1 million times. And this is how shaders works. And the GPU is so good, actually. The GPU is so great in parallelism to do every code, like every pixel in parallel. So it works right out of the box, right? Every game also has shaders. So if you move around in a 3D world, right? So everything there is also shaders and also gets executed on the GPU. And this is how Flutter works, and this is how shaders works, right? And you can redraw some parts, some pixels on the screen. So if you don't need to redraw a pixel every second. So for example, Flutter, if everything's drawn, right? So you have an app which has with no animation, then you draw pixels and then you don't need to redraw them. So it's kind of performant and smart as well. So it tries to figure out what to redraw and what not, right? This is what Flutter does under the hood. But in the end, everything is drawn on the screen. And this is how shaders work. Of course, this is one of the simplest shader out there. So you have just one color, right? And depending on how big this shader is, so you can move it, let's say, you can place the shader, let's say, here in this column, right? In this table set. And this is one shader with just one color, right? So this is, in the end, it's this piece of code with the specific color of this color in the background, and then it's just executed on those pixels on the screen. So the GPU and the program behind it knows where to do that in the end. This is also what Flutter does. Right, and of course, those shaders can be more complicated, or let's say more just bigger in the end, and also smarter, and it can execute it in different ways. And this here is the shader I just showed you. So this is the piece of code to do the waves and animations and everything on the screen. So this is a GLSL shader. So this means it has some kind of syntax in the end, and this will be loaded in the system and then executed on the GPU. And
Okay,
this is
Alex, can I ask you to maybe turn on a white background, because we see your code very poorly? Is it possible?
I can. So the problem is this.
Okay, it's a PowerPoint. Okay.
This is a black. I'm not sure if I can change that. Let's see if I can change these. Actually, it's probably not so fast.
Yeah, okay, you have a lot of slides. Never mind, then we will share the presentation with everyone a little bit later so they can read from their phones.
So you cannot really see that at all. That's not possible.
Yeah, well, we see a little bit, but it's really hard to read. Yeah, we only see that there are white letters.
Damn. Okay, let me let's see if I can. Oh wait, let me just open Android Studio and use a white background and paste the code inside, maybe.
Yeah, that would work.
Oh, I updated the Android Studio, 1 second. Or I can just use Sublime Text. Let's see if I can use a different background. Or is Darkpad also? 1 second. Oh, it's also, the Darkpad is also black, right? So you cannot see that as well, right?
Yeah.
Damn, okay, maybe I can, oh yeah, this one here. Okay.
Okay, and maybe...
Yeah?
Yeah, that. Yeah.
Much better?
Yeah, much better. Thank you.
Okay, this is now because it shows some errors in the end because it's not dark.
Can you zoom in a little bit more? Bigger letters.
Yes, I can also do that. 1 second. Maybe I can also open the project just to recent project, because I can.
Okay, maybe we can zoom in the presentation here.
The zoom in the presentation, you mean?
Okay, we did it. Jel vam ok ovako? Malo bolje, a? Okay, we zoomed in the presentation, so we focused on the top left corner, and we have bigger letters now.
Okay, can you tell me where you see my cursor, where you don't see my cursor anymore?
No, we see it.
So still?
Okay, now we don't see it. So we see like R from the run.
Ah, yeah, okay, until here, and then probably here something, right?
Yeah, we see the error messages, but not all of them.
Okay, the error message you don't need to care about because it's not Dart in the end, it's GLSL. And let's look at the code. So in the end, so now here again, so let me show you also the easier shader. Again, let me just, where's my presentation? Here, the easiest shader was this one. Let me also move this here so I can switch better. Okay, so this is, I can also move it a little bit. So, okay, this was the easiest shader if you have seen it before. So it's a main method, and then you have a vec4, and then you have the values like RGB. This is what I told you before, and also the alpha channel. And the R is just the red color and the green and the blue color. And if you this will print a red color on the pixel in the end. And yeah, this is the easiest shader. And now let me show you the more difficult shader, which is this one here. So you have a main method. This is and then you mathematically expressions of vector multiplication and also some loops and whatever you want to do there. So this is again executed on the GPU for each pixel. Okay, and then you have, of course, this opens again. You have a frag color. This is in the end also what gets out. So you usually have like an input variable into the GLSL shader and also an output, which is always a vec4 in fragment shaders, because the vec4 is 4 points and always needs 4 points for the color, so RGB, and also the alpha channel. So you basically return after the shader is executed, you will return a color. And you can or calculate the color before you put it out. Okay. I can live showcase you there, and I hope you can see that now. My tablet turned off. Okay. So you probably just see the top left, so I will focus on that. I will move this here, right? So you see probably a little bit more. And let me just remove something here. By the way, my wife always hated that I occupy the tablet, because when I do some updates, I work with the tablet here, and I removed all the calendar events he put in, and I apologize all the time. So I'm destroying always the calendar, and today again. So it's I need to save somehow. Okay, let me activate the shader again, and it will follow my position on the screen. I'm not sure how good the frame rate is on your screen. This looks actually pretty well and has 60 FPS for each shader. I can switch to a different shader, and this one is a much faster shader. So I increase the values there. And this one is also a different shader. So this is one shader that someone did on the internet. I can also use different like GLSL code, which already exists inside the internet, to just put it into your Flutter app. You just do some small customization or adjust the code a little bit so that it works on Flutter. So, and yes, you can see the gap. So it's the shader just gets executed on the calendar. So there at the very top, you don't see it anymore. So you can also say, hey, I just want to have this shader here in this region. This one is also a different shader, but this is not so interesting. This one is one of the complex shader I think I saw. And this shape, in the end, it changes it. There's some mathematic algorithm that depends on time, and then it moves something around. You always see my writings there, of course. Let me remove that. So this one is, I think, the coolest shader. I saw so far, because it looks really nice. And you can also, you see it at the very top left, you can also enhance widgets in Flutter. This is, I think, very interesting. And you saw the menu before, and I use a shader to get this widget and change the color, or also the position and the appearance of this widget. So I can basically you just use the Flutter widgets and enhance it with shaders. And I will show you how just a basic understanding how this works. And now, of course, you have an issue with the color of your screen. So I hope I can just put it inside here, and I hope you will understand. So what I told you before, you have an output color, right? So this is the vec4, and you have input parameters or attributes or variables, whatever you call it. And I need a resolution of the screen, so I need that as well. So I can pass it into the shader. I can say, hey, the screen is 1920, so HD, and you can put it there. You need to pass time, because when you don't have a time, then you always have the same output, right? So if you multiply, or if you add 2 plus 2, right, it's always 4. So when you execute a shader without something that changes each frame, it will always output the same. And so you need something that changes on each FPS, and usually you do it with the time. Let me just drink something. And of course, like if you have, because this code gets executed numerous times, the time for each frame that gets executed for the same time should be the same, right? So the algorithm that you are creating depends on time. So the pixel at the very top left knows the time and also knows, okay, at this point it's just a black color, right? And in the center of those points, it knows, okay, this algorithm gives me the color of green, right? So and so over the resolution of the screen, you basically print the screen by its color, and this is how this works. You also need to know, okay, this is the speed I just put in, and this is the output variable, and you also need to know, okay, where am I at the moment? So am I on the screen? Which pixel do I need to calculate now? Right, so you go there and say, hey, I have this coordinates here. This is the Flutter record. This is this comes from. I have this open. No, I don't have it open. You put in a Flutter library in this shader. It's not here inside. It's it would be above that, but I didn't put it into the presentation because it was just too big. But if you call this function in the main method, because this is the main, the first code that gets executed, you will get the current coordinates here. So, and this is the vec2, and the vec2 we know, okay, this is an x and y value. You can also put different variables in it, and for example, the mouse position. So I showed you that I can move around the shader, right? So I need to know where the mouse is, right? So I have the coordinates of the current shader execution. So let's say at the very top left, and the mouse coordinates, and the resolution. And then you can just do the calculation here. And at the very end, you just return. You just return the color of the vec4. Okay, let's look what I have here. This I explain now in detail on the screen. And now let's say, okay, we already did the Flutter, the shader, right? I can just put a color there, or just this algorithm, and I want to put this into Flutter. And hopefully this will work now without issues. Okay, they don't know the shaded classes and so on, but still fine. That works for now. So we use the custom painter. And what I showed you before, so let's say, let me show you the stack again, the custom painter at the very top right, because the custom painter can have access okay, has access to the Canvas API. We just presented to make it bigger. And the custom painter here, I think you see it, has access to the Canvas API. And this can be used to paint something or paint a shader on the screen. And here you have the shader. This I didn't show it here, but you need to load it before. So you need to load the shader file, which is the GLSL file and the frac GLSL file, and you load it here. You can see it in the repository if you know how it works, but this is just here for an example. And on the paint method, so all custom shader, custom painter has a paint method where it just paints the new the new things you want to paint, and then you create a rectangle from left to right or from the top left to the top right, and say, hey, how big is this one? So this is the big of the size of the screen in the end, and then you can paint it. Right, so you, in this case, I didn't use a shader yet because I didn't use the shader variable so far, right? So it's not yet there inside. How do I put it inside? I need to switch now from this to this. Okay, you saw the difference. So you can use the paint of, when you draw the rect, you can use the paint and add the shader, what you loaded before, and add the shader to the shader of the paint. And this is enough for showing the shader, which does not update yet because it's just a paint method without updating something. You don't have a time variable here. You have nothing. You just have the shader file, and that's it, right? And now the question is, how do I put it? How do I put in the variables inside? And this is how it works, how you put in the variables into the shader. You saw before that we used the variables of the screen resolution, and what you saw before was vec2. And in this case, so you have the paint method here, which you also saw before. And into the shader, we just set floats, for example. And we need to add like a position of this float. And if you have a uniform vec2 input variable, so you need to have two variables, right? So you need to put the width and the height at like a first and second position. And then the shader knows, okay, these two parameters need to go into the screen resolution. And you have the time, you have the mouse position, you have the speed, and you can customize it yourself. This is in the end the float variable, right? And then you just add the shader to the screen, and then it will use the shader variables and print it or display it on the screen. Still, it's not updating. So you need to really say, okay, I don't want to paint it just once. I want to paint it as many times as it can be painted. And in this case, I think I didn't put it into the slides. No, I didn't put it in the slides, but yeah, no, I didn't put it into the slide, but you can say, okay, I have let's say an animation that is running, or I say there's a widget that tells the custom painter, hey, I want to update this paint every frame that the device can do. And then it will repaint all, like every frame, it will repaint the shader. So if you have 60 FPS, it will do this code 60 times per second. In the end, it will update the variables 60 times per second, and then it will do the paint and then draw the rect again. So it really redraws everything every frame. And this is how shader works in Flutter. Now, enhancing widget, I showed you before that you can also enhance widgets, and I just want to show you how this works on the Flutter side. And also there's, of course, a widget for that, which is called the shader builder, where you also have the fragment shader and the widget you want to put it, like use for that. And then you have a sampler. So you can imagine that the widget, let's say, do I have it? I think the connection is again broken. Yes, it's broken again. Let me just quickly. Yeah, this widget, for example. So this, in the end, is a widget. and you can put it, like, use this widget and put it into the sampler, right? This is then the widget child. You can imagine this is the menu button at the very top left. And then what it does, the animate sampler, what it does is it generates an image of this widget. So in the end, what gets drawn on the screen is just an image, right? So just some pixels, and then this image, you can put it into the shader in the end. So and this is how you can change widgets or enhance widgets with shaders. It's pretty simple in the end. So in the end, you have an image what you can use inside the shader, right? And I think I have it on the next slide how this works on. No, I didn't have it here, but in the end, you have. Oh, let me show you the shader again. In the end, you have just a uniform, and then in the end, you have the image as a variable, right? And you can access the image pixel. Let's say the pixel, if you know the fragment codes of this image, so the coordination where the shader is turned on or executed, you can use the image and get this pixels for the image, and you can enhance basically the pixels of this image. So you can make it, let's say, black and white. You can also do that, or you can do it some crazy filters, so Instagram filters. You can also do with shaders, right? So and shaders is so powerful because it gets executed on the GPU. So you can really do crazy stuff with that. And in our case, or my case, how I played around with that, turn out again. I just used it, and well, actually, I used the Flutter. There's a Flutter example with exactly this shader, and this is how I learned a little bit how this works. And yeah, I used it at the pixel and so on. Yeah, and if you want to go into the world of shaders, because GLSL is not only for Flutter, it's an open standard out there and used by a lot of people. There is Shader Toy. This is the website. I can go there now. Let me just go there and show you. This, for example, is a shader. Or let me go take something with brighter colors so that you can see it. Let me just browse it a little bit. Maybe this one. Oh, this is also too dark, right? Maybe this one. So here, this is also a shader, right? It calculates the color for each pixel, and the code. Okay, over here, so I move it here. So this is the code of the shader. So everything is open source there. This is more like a shader art. So everyone is doing something, like calculate or doing the math for shaders in the end, and they can showcase it here. And there are so cool projects. So this here is the one I showed you before. And what I did was I just copy pasted the code here in the end and do some changes for the fragment coordinations of the current pixel, because you need to use the Flutter one and not the one from the shader toy. But the calculation is the same. And also there's water shaders out there, which is really cool. So this is in the end a shader. So this is usually used by games in the end, but you can also use it in Flutter. And this, I think, was it for today. No, I have a really cool example. There's this observable Flutter showcase. This is from one of the videos. You can watch it online. But I wanted to show you this because I liked it very much. Let me move it to the top left. It's unfortunately black. Say again, sorry?
No.
Did you say something?
No, nothing.
Okay, so I hope you can see it. So this is the game. Oh, there. I got confused by the voice, but it was in the video. Sorry for that. Okay, and this is just a game in the end written in Flutter, and this is without shaders. right? So it looks very, very, I would say, basic, right? And if you now turn on the shaders in the end, so what he wrote, then it will look like this. Let me turn off the voice again. Yes. So here. So this is then the same game what you saw before, but would turn on shaders. You see there the let me pause at the right position. Yeah, you can see some water, and so water. What how you call that? This like display? No, the water reflection. You see the water reflection of the ball. You see the ball moving top to the thing here. They have a cool shaders. You can really enhance your widgets, your game, your app, whatever. Really cool with shaders. And of course, it's very very complicated. Um, and it's really complicated to start with. And I can, if you want to start with shaders, there's this introduction to shader art coding by Kishi Misu, and he did this shader here, what you see here, and this was a really cool Kickstarter for me. And this is how I got into shaders and understood how this works in the end. And yeah, I think that's it for now. I almost 45, so on time, I would say. I'm open for questions, and you can download the app, by the way. So it's the Stiftkalender for tablets. You'll probably need to search for that because it's not really popular in the App Store yet, but it will increase over time. So if you have any question, please.
Okay, so we have no questions at the moment. Thank you very much for this presentation. Can you maybe send this presentation via email so that everyone present can have a look at it, because we will have a quiz later for rewards, so they can have, like notes or something.
Yes.
Yeah, thank you very much.
I will send it to you.
And thank you again for this presentation and for taking the time to talk to us. And can we have a round of applause for Alexander here?
Yeah, thank you very much for having me, and also hopefully you could see something, because this is a very visual presentation in the end, so with tablets and so on. So yeah, have a nice day, and we can connect on LinkedIn if you want, so feel free to contact me if you have any questions. Then have a nice day. Bye bye.
Thank you, bye. Kad skupimo sve 3 prezentacije, ćemo vam ih poslati da biste imali kao materijale za kviz. A u međuvremenu ću da vas zamolim samo kada popijete bilo šta, sačuvajte čepove da možemo posle da ih odnesemo u čep za hendikep. I to je to. Imamo sad pauzu jedno 15 minuta do sledećeg predavanja. Da. Aleksandar. Thiele, tako nešto, ne znam kako se to čita. Thiele, otkud znam. Da, ima nagrade. Thiele, tako se preziva. Ovo se pravim, baš me loša rezolucija, ne znam možda neko cijeći. Ne, ovo je najbolje. Možemo li se malo... Čekaj, ću da... Da se bolje moram pa veće, ja mislim. Mislim da nije ništa bolje, ali veće jeste. Pa stari je projekat i zvukovi iznastaliran. A to su veće. Ja, malo to sam. Onako ne znam da je. Kako se on čuje kako više. Mogu da nađem nekako da ovo gasim, ono YouTube.